Hi, in this tutorial we will create simple Amazon Alexa skill with the backend on Java, and the text will be also published on the Medium. We start with the developer console to create Alexa skill. Select the section Alexa. In your Alexa consoles, select skills, hit the create skill, enter the skill name. Let's put it this way. Keep the custom design as selected, hit the create skill button. We have options and we will use start from scratch without any templates. Hit the choose button. Here we have the dashboard for the Alexa skill. First we need to put the invocation name. As you can see, this warning here. Invocation name, this would be the name which we will use to invoke the skill from the Alexa device, and it has some limitations, so you shouldn't use wake words Alexa computer, Amazon or Echo, because device can be called Alexa computer and Amazon, and when you pronounce this word it starts listening your command. And save the model. Then we navigate to intents, and we need to add at least one intent. Intents are kind of templates of sentences which user pronounce when request something or command something to Alexa. There are some predefined intents which react on the particular words. For example, stop intent reacted on stop, cancel on cancel, etc. And we add intent, and let's add something simple and not much meaningful. It doesn't need to be name intent here, it is just agreement if you want to use it. Create custom intent, welcome, and just put some sentences on which the machine would learn that particular sentences belongs to welcome intent. So intent would group our sentences to some similar purpose. For example, here we would have some questions like what can I do? And we can also add slots to those intents, and would be some placeholders for particular words or terms. In this tutorial we will not touch it. We just assume that the machine will recognize those two sentences as belonging to this welcome intent. And we save the model. All the time we change it, just not to forget. Then we can add some interfaces. Currently we will not add any interfaces. For example, display interface would be for devices which has the display. We navigate to endpoint, and endpoint would be the URL to the service which works as the backend for handling request of the Alexa skills. We will select AWS Lambda. Here we should put the Lambda unique ID, and we also have here your skill ID. This is unique ID of the skill. We can find the same skill ID actually in URL. We can copy this to clipboard, and we will use it a little bit later within the creating of Lambda. So next step would be to create the AWS Lambda function which would handle this Alexa skill. We navigate to AWS console, sign in, and in services we can find this Lambda, or we can type in the filter field, and then we create the function. We can use blueprints, predefined templates, and some existing examples, but we will start with the scratch. So we need the function name, and we need to select the runtime, and in this case it would be Java 8. We will not change anything within the existing role, leave it as it is, and hit the create function. Then we've got this Lambda function dashboard, and we need to add one of those triggers, and it would be Alexa skills kit. When I click here, we've got this box within the function configuration. When it is selected, there is the section with configure triggers for this Alexa skill. And here we would need to put this skill ID, which we copied in the Alexa skill dashboard. And don't forget to hit the add button. And now you see the save button highlighted, so we need to hit on save just to save those changes, as you can see. And this is unique ID for the AWS Lambda function. I copy it, come back to the Alexa developer console, and in the default region we put this ID for this function, and we can put different functions within different areas. We have 4 areas. Then we save endpoints. Technically we already configured the Alexa skill, so we proceed with Lambda function. What we need now, we need to create the code which we can upload. So it would be in Java code, and I will create it within the IntelliJ IDEA. There is also community version which is free, and we hit the create new project. I use Gradle for this. It is pretty similar to Maven, but more easier in my opinion. Select Java, project SDK would be 1.8, hit next, put the group ID. This is unique ID of the group of your products. I use in this example the URL to GitHub account and some name which describe the logical content of this project. Ask is meaning Alexa skill, and the artifact ID would be the product name, so it would be funk, for example. This would be your version ID, which can be changed, and snapshot means the ongoing development, but we don't need to change it. Here we don't need to change anything. You can use after import if you wish, but you can turn it on afterwards. Here we would put the location for our project on the disk and hit the finish. And now we wait while the project is setting up, and when it is loaded, it also updates all the Gradle related infrastructure, and then we would need to change our build Gradle file. You can configure Gradle wrapper. Okay, as you can see, this build Gradle has the group name which we entered. Second Gradle has the project name, and repository is used the Maven Central. It can be added more different repositories, and dependencies. This is what we need. So currently by default we have for test only reason the JUnit, and it is such a version. If I put cursor on one of these places and hit Ctrl space, you can see different groups and different products within selected group and different versions. We need to add more dependencies here. When we add some dependencies, we see this prompt to enable after import. I'm doing this because update and downloads the needed libraries, etc. And in the Gradle view, you can find in the section source sets, main, dependency, and you can see those dependencies downloaded, and those dependencies also contains dependencies they need. And so we have 2 here, and also dependencies you can see in the external libraries. They're all here. The next thing we need to add is the jar task. This particular task is the way to put those dependency libraries within the jar file which we will create. And to build the product, you can run one of these tasks. And when, for example, you run such task, it would run one by one task till the one you selected. For example, we can just build it, right-clicked, build, and in the run you would see the list of running tasks. So it looks fine, and now we select jar task and run it. So it would perform the same task, and then it would make the jar file. And we can see in the build, leaves this jar file. If we would need to change the version, we would need to change this version and the jar file would have it. We can find this jar file with the Finder in the Mac or Explorer in the Windows. You can see that it contains 11 megabytes of libraries. This is because all those dependencies which we see here were put here. And without those dependencies, AWS Lambda would not work. You can also use this menu to copy path to the jar file. We would use it to upload this to Lambda dashboard. This is minimum what we need. Then we need to create the code itself. We need to add handlers. So in the source main Java, I create first package. It's optional, but I prefer to have it. And it would have handlers in the path. It can be anything, it's totally up to you. Then we create handlers, create Java class, and the first handlers would be for any request which is not recognized as the intent. So it would be something launch request handler. And we will implement predefined interface and implement methods. One would tell if this handler can handle the request. If result true, it would be supposed to handle it with this method. It should return the response as a result. And we will check that input matches request type, import static method, launch request class. So this launch request is actually a request which represent something which is not recognized as some specific intent. And when we want to respond, we need to build the response from the input response builder with symbol card. And symbol card has title and card text. And this symbol card would be shown within this display interface. But we will respond with the speech. And this would be, for example, some introduction. And we need to build it. And then we add another one which would handle our welcome intent. If the system recognizes the sentence of the user as the welcome intent belonging, so it would be something like what can I do, etc. So this request supposed to be requested. We implement now a request handler. The same set of methods, and this one matches intent name. And our name is welcome intent. It's just a name we made during the creating of the Alexa skill. And it's supposed to respond with its own response. And here we can put welcome, for example, and build the response. Now we have two request handlers. This one and this one. And then we need to call them during the interaction with the Alexa. And for this we need to create stream handler. And it would extend the base class skills stream handler. And we will create the constructor and request super with standard, and we need to build it, but we need to add our request handler here. Then we can build it, see that we didn't miss anything. And technically this is minimum we need to make a backend for the Alexa skill. So if we navigate to Gradle and run the jar task, so it would build this new version of the jar. Then we open it in the Finder and double check that it actually built it. So this is when it was created, and then it was rebuilt again. And then I copy the path here and navigate to AWS Lambda dashboard. And then in this dashboard I find function code, hit the upload, find this jar file, open it. You can see it here, and we need to hit save button. We also need to change the handler. It would consist from package, class name, double column, and the handler response method. Technically, we can use other method which you can create within this handler class. By default, it is implemented with this name. So it would be this package, class name, and by default this name. Then we can hit save button and the function is ready. What I would suggest, next step would be the test of this Lambda function. So we can configure some test event. We can select Alexa templates, for example start session, and we can call it, and it would have the same structure as it is supposed to be for the requesting the Lambda function from the Alexa skill. Create the test, you can modify it, and then we hit test when it is selected. And then we have this result. If it is success, then everything is fine. We can look at the details, and this is the response from our Lambda function on this request. And as you can see, we have this response with a speak and the result, and the text is this is a simple Alexa skill example. And the reason is it is not welcome because the request is not recognized as the welcome intent. By default it is handled by the launch request. That's why we created two, welcome and some launch request. Now we can navigate back to the Alexa developer console and navigate to invocation and build the model. When we build the model, the infrastructure learn intents and they consider all the settings, and after building model we can test it. So let's remember it would be invocation name as simple example. Then we would refer to this invocation name, navigate to test. In test we need to enable development and keep this checkbox for skill ID. It would allow us to see JSON input and output here. Device display responsible for using the display interface enabled devices, which is not used now. And then we need to type here something like invocation name and hit enter. And then we can see this is the progress of simulation request to the server. And if you see something like this, it continues quite long. In my case, it is the issue with the blocking of this request by antivirus, and particularly Web Shield. What I do every time when I navigate to test tab, I open the Avast settings, preferences, and disable Web Shield. And then I can do this again. Hit enter, and so we've got the response from the handler which is responsible for found intent request, and we can see the input which was sent to our Lambda request, and the response was exactly this one. Now when we got this response, I turn on my Web Shield here and I can continue working with the antivirus. Turn it on. Next would be attempt to request something which would be recognized as the welcome intent. Welcome. So I typed the sentence which expected to be within the welcome intent content or similar. It don't have to be exactly the same, but to make it more flexible, we need to add more sentences, 5, 10 similar meaning or similar purpose sentences. Then the model would learn these sentences recognizable, more flexible, or with more variety of different words. So we've got the welcome, and this welcome we've got from this intent, from this welcome event handler, and the request was about the welcome intent, as we can see. And if this intent would have the recognized slots, they would be also within this part of the request. So technically our skill works, our backend is ready to be extended, and skill can be extended as well. I would suggest that we add some logging to this skill. Sometimes it is useful to have the logging of some information, some warnings or something else. When we work with Lambda, we can find those logs for particular request within this request, and we can find it in the CloudWatch log. You can see the log streams, and you find the stream which is latest for us, and one stream can contain log for several different requests. To write something to this log, we can use the Log4Net, which is within the dependencies here already. And this dependency Ask SDK core within the Ask SDK has the dependency for Log4J, but it is missing the Lambda appender, and that's why we added this dependency here. By the way, we can write it different way in this dependencies block. We can, the group, for example, and just use column to separate group, name, and version. So it is exactly the same. If you look at the log, we can find such error that no Log4J to configuration file found, and the default configuration only reports errors to console, and we, for example, want to add information or wording, etc. Then we added this Lambda appenders component in this source main resources. We create the file, and note this too. This is the version of this for the Log4J component. There is also version without 2, and it's not recommended to use. So Log4J, which would have such content. This configuration you can change. By default it was error level. Here we have info, we can have warn, etc. This is the Lambda appender, and this is the pattern of the message, which can be also changed. Please look at the links in the description for the reference. And we can use this logging, for example, in this custom launch request handler. We would like to tell something that we don't know what is this request about. So we need to create the logger here. This logger would be for this class. And now we can log our text. Info, error, warning, debug. In our case it would be info. We can put something like, and then we can put what is actually inside of this request. And input contains the request envelope, and we can put the get request envelope JSON to this log. It is ready. We need to save it and go to Gradle. In the task, right click this and run. Actually last task can be run from here. Ctrl F5 in this case. We build it. Let's double check it is built correct time, and then open the Lambda dashboard. Navigate to upload. Always double check this that you didn't get the wrong file actually here. Open, hit save, and now we can test it with our internal test first. So hit test. Okay, and then we get this message. So receive it and recognize it, and session, etc, etc, and all this actually from this test. But we can test it as well within the Alexa. So we can again request for open simple example the way we requested this first time, and probably we would need to turn off the antivirus again. So we've got this request, we've got this output, and then we navigate to CloudWatch log, look at the latest one, look at the request log. Here we have to find the received unrecognized event, and the time here is UTC actually, and it is launch request. This one is from the Lambda test, and let's look at the more later one. And it is the same, receive it, blah blah blah, and here we get the session ID, application ID, and some user ID, not the test one. Now seems it is up and running, and I'm pretty sure we have this skill ready for the development, extending, improvement, and Lambda function as well can be extended, improved. And this is pretty much it, what we can tell for this very simple skill and very simple backend from this skill. Thank you for watching, and see you next time.